For covalent binary compounds made from the elements of two nonmetals, the name is given by telling the number of each type of atom using Greek prefixes. There's only one atom of the first element. The mono is going to be omitted. We'll talk about mono in just a second. The name of the second element must end in the suffix IDE. So that's our general overall rule that we're going to be using. First, we got to know our Greek prefixes. Mono means one, di means two, tri means three, tetra means four, penta means five, hexa means six, hepta is seven, not septa, but hepta, octa is eight, non is nine, and dec is 10. Many of these you know already. So what we're going to do is tell the number of each type of atom. And so we got some examples here. The first one, N2, Br2. We're going to get the name of the first atom in the covalent compound, then the name of the second atom, except we're going to change the bromine to bromide, use that suffix of IDE. We have to tell the number of each type of atom. There are two nitrogens, so it's going to be dinitrogen, and then tetrabromide, with the correct name for N2Br5. Now you might be asking, how did we know that it's a covalent compound? It's composed of two nonmetals. Nitrogen and bromine are nonmetals, and hence we use the covalent nomenclature. Likewise, for P2O4, both phosphorus and oxygen are in the upper right-hand corner of the periodic table. Thus, they're nonmetals. We're going to tell the number of each type of atom. We've got two phosphorus. That's going to be diphosphorus. Then we've got four oxygens. So instead of saying tetraoxide, though, we're going to drop the A and just say tetroxide. Diphosphorus tetroxide. CO2 and CO. You've known these for I don't know how many years. Now CO2 is carbon dioxide. We don't say monocarbon dioxide. If there's only one of the first element, we leave off the mono for simplicity's sake. So that's CO2, carbon dioxide. Compound CO is simply carbon monoxide. Well, once again, we're going to leave off that extra vowel when we're talking about a compound that's going to contain oxygen. So it's not monooxide, it's just monoxide. So let's practice looking at these compounds. First, we've got two nitrogen compounds containing oxygen. So the first one becomes nitrogen monoxide, not mononitrogen monoxide, just simply nitrogen monoxide. And the second one becomes nitrogen dioxide, parallel to the CO2 and CO that we did just up above. Let's skip down to N2O4, while we're talking about nitrogen and oxygen compounds. This is going to become dinitrogen tetroxide. Leave off the A from tetra, just call that tetroxide. So those are three different nitrogen compounds that contain oxygen. P2O5, diphosphorus pentoxide, diphosphorus pentoxide, P2O5. So we've been writing the names given the formula. You also have to develop the skill of writing the formula if given the name. So let's do these next four compounds. Iodine heptafluoride, Atomic symbol for iodine is I. And fluoride comes from fluorine. We only got one iodine. Even though we've left the mono off the iodine, it's understood. Hepta is a Greek prefix that means 7, so IF7 for iodine heptafluoride. Selenium dioxide. Selenium is Se, capital S, lowercase e. Oxygen is O. We got one selenium, but we have two oxygens to make it dioxide, SeO2. Triphosphorus monosulfide. So phosphorus, we'll have 3 of those. We know that from the tri. The monosulfide, we got a single sulfur, so P3S. P3S will be the correct formula for triphosphorus monosulfide. Lastly, bromine pentachloride. We've only got one bromine, the mono is understood, and then for the chlorine, we've got 5 of those. So BrCl5. Covalent nomenclature is fairly straightforward. The hardest part is just remembering the prefixes, many of which you know. Hepta, octa, non for 9, and dec for 10. Those may be some that you're not quite so familiar with.